All right. Welcome back. So here we are, we're in Module 4. So this is a substantial text. There's a lot of information here, far more than we're going to cover in this course. But the good thing is, your palmbeachstate.edu email address allows you access to this title as long as the subscription is good with the college. So we've paid for a subscription. It allows all the students to have access to it, as well as other titles. Just about anything. We go do a search up here and get to whatever we want to get to. And Module 9 will deal with another textbook. So when you get into the overview page in Module 9, it'll point off to another text, not this one, and that text will deal primarily with mobile devices and using C# for programming with mobile devices. Now, with that said, it's clear we've got a ton of information available to us. Are we going to cover everything in the book, everything in every chapter? There's no way we could, even if this was a full-term course. The initial term that I'm recording this video, it's a short mini session for the summer. So there's no realistic world in which we could cover all of this and you survive it. So we're going to hit on the key points and apply the skills that we're going to need to apply to address the course learning outcomes that we've got listed on the front end of the course. Should be up on the course homepage. And we'll get through all of those. You'll be prepared to move on to the COP2360 course if you're taking that next, depending on the program you're in. Okay, so with that said, this chapter builds on the foundation of what we dealt with in chapters 2 and 3. The quizzes you will see in chapters, I think most of them moving forward, will be reinforcing concepts primarily from chapters 1 through 4. There may be some sprinkled in from other chapters and concepts that we cover in the lectures. But primarily, it's going to focus on concepts from chapters 1 through 3 for the most part, but it'll have some 4 in it too. So that's the quizzes that you have. You can take them as many times as you want on the ones from chapter 4 on, or from module 4 on. And if you haven't done so yet, the time that you're listening to this, make sure that you get your group submission submitted by the due date. I might have left it open to afford some extra time, but then again, that may not always be the case. So the due dates are the due dates, DUE, not DO. So with that said, let's jump into this and we'll talk about delegates and transformers. Now, many of you would know what a proxy is, a proxy server. And most times when I have to explain what a proxy server is, I say, well, it's kind of like having somebody act in your behalf or do whatever's got to get done in your place. I remember teaching overseas years ago, and the country that I was teaching in would not allow access to a number of different sites that I needed to get access to. And my way around that was through a proxy server. I had that server act on my behalf. So the servers that I wanted to access were shielded by the proxy. Now, we see that from time to time in the things that we do, and it's a way to kind of cloak ourselves. I don't want to have to do the dirty work. I'll have my proxy do it for me. Or I didn't actually go there, my proxy went there for me. So with that said, we're going to use that concept and apply it in C#. But we're not going to call them proxies, we'll call them delegates. They're going to act on my behalf. Now, in politics, delegates, same kind of concept. So we're going to create a delegate to interact with some method, and it will shield that method, so we don't actually touch or interact with that method directly. But the method we're going to interact with returns some value. So this delegate is going to be our proxy. It's going to give us whatever it goes to get for us. Let's think about it like the Instacart. All right. Instacart will give us groceries. That's the type that it's going to return to us. I interact with this delegate. I can call it whatever I want to call it. And they call this one transformer. And say, Instacart, go to Publix and get me groceries. And it does that. And the transformer then brings back, or Instacart then brings back the groceries to me. I never directly interacted with that method, that whole thing with Publix. Instacart did it for me. So that's conceptually what's taking place here. So we define it as a delegate type. The data type that it's going to provide me, the name I'm giving it, and it's going to receive from the method that it's going to interact with that same data type, and it will call it X. Okay, that's how this transformer is going to work. And then we can go through and say, all right, transformer T equals square. What's square? Well, square, it's a method we defined. It receives an integer and returns an integer. Our transformer receives an integer, returns an integer. Okay, so we've got this method called square. I want to have it do some work for me, but I don't actually want to interact with it directly. Now I can write this either way, but what I'm going to do is I'm going to say transformer T equals square. By doing this, T becomes an integer transformer, and it will receive an integer and return an integer, because that's what our transformer does. Our integer transformer, it returns it and receives it. Okay. So then I say int answer, and then I invoke my transformer that I called T. I pass it the number 3. It then takes that 3 and it essentially does the same thing that square would have done. It receives 3. 3 times 3 returns that 9 as an integer and puts it in answer. I didn't directly interact with square. I interacted with the delegate t. So that's what's taking place there. So there's two ways we can go about this. I can do it with delegates, and they've got some examples of delegates here. Or, scroll down, and the delegates are interacting with, emphasize this, methods. Okay. So, come down, let's deal with more delegates, different types of delegates. Now we've got something else called an interface, but as they say, a problem that you can solve with a delegate can also be solved with an interface. It's about the same thing. Just going about it with a different syntax. Okay, so we can have an interface transformer instead of the delegate transformer. Okay. And here's we go declare it and go use it. Okay. So in much of what we're going to do, there's more than one way to do it. All right. So there's two different ways to perform about the same task. All right. Now, like I said, dealing with methods. The delegate has a specific data type, and whatever you use that delegate to interact with has to be returning and receiving the exact same data types as the delegate has been defined or declared to use. So the parameters, the returning values, all of it has to be aligned with, and it's, so if it's a string, it's a string. If it's an integer, it's an integer. All right. So we've got to have that compatibility. Now, we can run into some problems along the way, but hang on. Let me push off the problems that we run into. We'll talk about that in a little bit. The next spot that I want to jump down to is lambda. There we go. So I can have a lambda expression. I said before, I said, you know, delegates interact with methods. Well, I can also have a delegate interact with a lambda expression. So I create a transformer, I call it SQR for square. And here's the expression to perform the calculation. So x times x equals x, and that is an assignment equals. So when we say x times x, we square those values. That's now assigning it to x. X assigns the value to square, so we have this transformer square. Much like we did up above. Now we can say console right line square 3, and squares our transformer. I never actually touched that expression, that lambda expression. It's similar to what I could do. I can create a method that performs this calculation, or think of this as a shorthand way of doing the same kind of thing. Here's my expression. Here's the value that I get from that expression. Just deal with that as a transformer, and I didn't directly interact with that expression. Now, think of this like kind of treat it like a constant in a way when we're going to do it like this. So you pass it a value. This expression always is the same. It's always going to be the same. The result coming back from it will change based on what I pass it, but square's always going to be the same. I didn't actually have to deal with the expression. I just dealt with this transformer method that I created. Okay. And then we just did our console.writeLine to print out the result of this lambda expression. So it's a method that doesn't have a name. So we didn't go through the formalities of defining a method name and doing all that. We just did it as a lambda. All right, so that's that concept. When I use the term shorthand, it's the whole rationale behind it. They created it, and it's not just in this language. They've created lambda to try to cut down on the amount of code that we got to write. Programmers aren't lazy, they're efficient. I say it over and over again. All right. Here's some more about lambdas. And then we're going to jump into something I want you to spend some time on, and you're going to have an individual project that you're going to do relative to this next concept. So here we are. Try statements and exceptions. Now, so what's an exception? All right. I think I don't know if they explained it up here. They talk about expressions. I'm not talking about expressions, I'm talking about exceptions. All right. When we think about the word exception, we think of the phrase exception to the rule. What's that mean? Well, things didn't go the way they were supposed to go. The rule is you do this and this happens. What's the exception? Something other than what's supposed to happen. All right. So when I write code, I have the expectation that something specific is going to happen. And in my mind, that's the rule. The rule is you do this and this happens. Well, what if the user enters data in the wrong format? What if you use an index that's outside the scope of the data that we have? What about that? In those cases, we have to be ready for bad things to happen. And what we do is we say, all right, I'm going to try this in hope that it works. But in the event that it doesn't go as planned, whether the user gives me the wrong data type, or I get some other exception, which is, think of it as an error in the programming, an error in the processes. We want to handle those exceptions because those exceptions can shut our code down. Well, I don't want everything we're trying to do to get shut down just because of one little hiccup, if you will. So what we're going to do is we're going to say, well, let's try this. All right, we're going to try it. Try what we would have done normally, but we're going to put in this conditional, if you will. We call it a catch block. So we're going to try something, and if there's an exception, let's catch it before it gets out of control and shuts our code down. So we've got a formal way of writing it. Let's try this, and if everything goes good, we don't have to catch the exception. We just run and we're done. And we've got this finally block at the end. The finally block allows us to say we're done. Tie up any loose ends. The program is done doing whatever we needed it to do. So it's almost like saying, all right, everybody in the car, we're about to leave. We got to make sure everything's wrapped up because we're done. We're moving on. So I try to do something. If it throws an exception, I catch it before it gets out of hand. Well, if it's this type of exception, exception A, I catch it and do this. Well, what if it's that exception? Well, I'm ready for that one too. So, man, how many exceptions do we have to be ready to catch? It depends on how unspecific we were when we wrote our code or the directions for the users, whatever it may be. We got to be ready for just about anything. We don't want our code to break. So this is how we handle it. You may have dealt with this in a previous course, you may not have. And the syntax, the wording used, it's not always try, catch. It may be something different. Conceptually, same thing. They may not have a finally block or a finally keyword in another language that you've used. So this is the syntax for C#. Let's try it. If it gives us a problem, let's catch it and handle that problem. Problem exception. So we think about an exception. It's a problem that came out of whatever we were trying to do. By doing this, we're keeping our code from shutting down. And the exception could be, give the user a little pop-up and tell them they entered the wrong data type and push them back to where they can enter another entry and try again. So we can create a loop, and if they throw an exception, let's catch it and send them right back up to the top of the loop. If this works, we break out of the loop and we move on. We can do that. That's the logic behind setting this up to, let's try something. If it works, we're great. If it doesn't work, what you gonna do? We could just shut the program down. Nice and clean, let's just shut it down. So it's depending on what we want to do, we can do whatever we want in these catch blocks. So here's example, divide by 0 exception. So if what's happening here generates a divide by 0 exception, and we say divide by 0, here's the exception that comes in, and the only thing we do is give the user a message that says, hey, x cannot be 0. And then once we've caught it, program's done. We didn't have a loop structure, we just went in, we tried to do this. If they gave us a value, or if we received a value, that was what it needed to be, whatever happened up here in calc. If calc had an issue in it, and that's what's happening, we're calling that method up above. If there was an issue in that, that was a divide by 0 issue or exception, all right, let them know. You can't do that. So it's a simple resolution. And then we shut the program down. And then we've got another call. So you caught the exception, and then you ended the program. So try, catch. There's a variety of different exceptions. You ran out of memory. There was an exception within the system itself. So I've got in the resources page for Module 4, I've got a video that'll walk you through try-catch concepts. In the assignment, I give you an example of try-catch. And then I want you to go and play with the code that I gave you. You'll have to write your own code, but you'll create your own C# program using command line interface, and we're going back and forth. If you didn't want to do console, you could do using system.console and bring that in, and then you don't have to be explicit here. I talked about that before. For whatever reason, they persist in having to be explicit here. I want you to go play with a variety of different types of exceptions. Now, like I said, the finally, that's what happens at the end. Regardless of an exception getting thrown, we will have finally to clean up whatever's at the end. All right. We've got other words that we could use to help us jump around in the code, return things, or go to. It's things that we could do. We could have an IO exception that gets thrown. So there's a variety of different exceptions, and you can go research different types of exceptions. And I've got code for you here. So there's a link to the publisher's resources with code resources, and this is where I pulled a lot of the stuff that you've already been provided, dumped into the GitHub repo that I've got for you there. But here's examples of code to handle different exceptions using the finally block. We've dealt with using before, but doing things a little different. So go through, play with these. This exercise, we'll call it an individual project, we'll call it whatever we want to call it for Module 4, and it's, I think it's quite easy. It's just you going and exploring with and interacting with try-catch code. Like I said, the other stuff that you're having to deal with now in the quizzes goes back to the previous modules. So if I came over here, so alright, Chapter 3, those quizzes could come out of here. Chapter 3, those quizzes could come out of here. Chapter 2. So those are foundational concepts in the quizzes that you'll see Chapter 4 moving forward, for the most part. All right. Like I said, you can go through and retake them as many times as you want, and you've got an hour to complete. All right. So with that said, I'm going to go ahead and give you time to go read through the chapter, play with the code that we've got here, and you can just copy the code and use it in your installation of Visual Studio, whether it's Visual Code, visualstudio.net. Now, this is what they word as advanced C#, and there's a lot of advanced concepts in here. Tuples, tuples, it's two different pronunciations, same concept. Talked about them before. It does not change. One of the things that I didn't talk about, and we'll talk about more later on, is enumeration or enumerators and iterators. And these are built-in methods that allow us to navigate structures like a string or a list. They allow us to iterate through each item within that structure. Pretty straightforward, but they're built into the class. All right. With that said, see you in Module 5.